Okay, so this is action potential. So to begin action potential, a stimulus of some sort is sent through the body to begin the process. So, it can be anywhere in the body, wherever the stimulus is. Um, and this message of the stimulus is transmitted from the brain to wherever the stimulus is located. So this one up here to the brain to wherever in the body. And it does this through these neurons. So groups of these neurons are known as nerves. Um, and each individual neuron uses a long extension that runs through the body called an axon. And this is used to transmit that message of the stimulus to the body. Those axons run from the base of the spinal cord to a muscle that is in the foot. Basically, it's a stick figure, but so it starts up here and goes all the way down. So that kind of shows the long extension. Um, Axons are used to conduct electrical messages called action potentials, which we're talking about. These electric messages are created with electricity, obviously, and this electricity is created by a quick reversal in the charges. So here's what the charges start off looking like. So positive outside, negative inside, and this is the cell. And when it goes through this reversal, it turns into this, which is a negative exterior and positive interior. Um, so uh, these are the original ones are what are reversed to this. This is what it turns into. Um, and when the inside of the cell becomes positive, it's known as depolarization. Depolarization. Neurons use sodium ions and potassium ions to create this polarity of positive outside and inside, or vice versa. Um, the membrane of an axon has many channels that will only allow sodium or potassium to move through. So these are what the channels look like, and here's a sodium channel, and here's a potassium channel, and then sodium ions and potassium ions. And then once again, cell exterior, cell interior, positive, negative. Um, and when a neuron is not transmitting an electrical message, sodium and potassium ions move through what is known as a concentration gradient through these membrane channels to the opposite side of the membrane. So sodium is up here, so it would move down here. Potassium down here, moves up here. Um, and at the same time, a special sodium and potassium pump maintains this concentration gradient by forcing the sodium and potassium back to the original side. So, like I said, the sodium was up here and was moving down here during that concentration gradient. But now, because of this sodium potassium pump, it is pushed back up with energy to the top, and same thing with the potassium. It's pulled back or forced back down to where it originally was located. Um, and through this special pump, uh, for every 3 sodium that are forced back up, 2 potassium are pushed back or forced back to the interior. And because of this, the number of positive charges on the outside is higher than on the inside, which maintains this balance. And this is driven by ATP, so that allows it to stay positive exterior and negative interior. Um, and then because of this, the outside of the neuron is positive when compared with the inside, and this is called resting potential. And repolarization is the returning of the cell to resting potential. It's just kind of extra. And during resting potential, sodium ions and are outside of the cell, and potassium are inside, so top bottom. And then in the end, a brief electrical current pulses down the length of the axon to transmit a nerve pulse. So the nerve starts out over here and it moves. This is the electrical pulse. It moves down the axon, changes the positive exterior, negative interior to a negative exterior, positive interior as it moves through, and then obviously it goes back. So it's that reversal, and it sends us throughout the body to wherever that stimulus was located in the original picture to, to send that message. So that is the process of action potential.